bit of a background from me. I've worked in data analytics for over 20 years now. My degree originally was in computer science with software engineering. I worked in external audit, so I've worked for PwC and KPMG, stayed there for about 13, 14 years, and then I've been with HSBC for almost 8 years now. HSBC, I originally joined in IT audit, so IT auditor, and there one of my roles was to start using more data analytics within IT audit. Worked there for about 3 years and then decided to move to First Line. Worked in First Line in cloud for about 9 months and then decided I missed audit. We shouldn't say this when it's been recorded, and decided to move back into audit. So I sit in the central analytics team at HSBC now. I've got a few things that I do within my central role. So I do a lot of the training of the auditors. I help auditors to develop analytics themselves. We develop analytics in the central team, and I'm also responsible for the innovation for internal audit as well. So I wanted to go through a few things, and I'm not doing this is where we will be, this is the Gen AI, this is the AI. What I wanted to do is to bring it more of a what you can do now. And some of you, apologies, might already be doing this, but some of you, it might be some new things or give you some ideas of things that are available now that you can use. So I want to talk about how data analytics has evolved. Obviously, I've lived through this over the last few years. I want to talk about the different types of data analytics, an overview of low-code tools, and then give examples of how we can use low-code tools for some more advanced analytics. So I've got an example with a video. I'm hoping that all runs well. And some k-means clustering in KNIME, and I've also got some sentiment analysis as well to show you. So I want to start it with the evolution of data analytics. So actually as internal audit. So according to Google, auditors became around in BC when merchants were verifying grain receipts. Yeah, little bit before us. And then in the 18th century, we had incoming counters and checks into the public accounts. So that's when we started sort of doing more paperwork. And then apparently, and hopefully this is accurate, in 1985, Excel was released. And obviously that made a big impact on the industry as things started to be more based on things using calculations, etc., rather than checking paper. And do that. 1987, has anyone used ACL or IDEA? So when I was young, ACL was one of the first things I learned, and also IDEA. So these were the original low-code tools that came out, and I'm going to talk to you a lot more now about the newer versions of low-code tools. ACL and IDEA still around, some people still using those tools as well. I've put in here 2014 an increased uptake in data analytics within audit functions. This is through Googling some papers that came up. So when I first worked at PwC, it was very much the auditors were still taking a sample, and you'd go and talk to the audit teams and they'd say, well, I don't know if I want to do data analytics, it's a pain to get the data, we've got to test the full population. And it was always us going to them and trying to encourage them to use data analytics. There's been a sway since 2014. You've probably seen this yourselves, where more auditors want to do data analytics. Everyone wants to do data analytics. They want to get the data. They want to use the new tools. They want to do it this way. And if you've got it as a central team, obviously that couldn't be maintained to deliver that analytics. And I'll talk about that more in a minute. And then obviously I've put 2024 for potential Gen AI solutions, just as from the forums and things that I go to with other banks and things, this is the years when people have started trying to implement some of the Gen AI solutions. So obviously this all has an impact on what your structure looks like. So historic structure for me, as I grew up with this, was there would be typically a large central data analytics team, and they would do everything. They would be your specialists. They would have the ACL knowledge, then the IDEA knowledge, the SQL knowledge, and they would do all the analytics for the auditors, and they would work together to pass the information across. What's happening now is that the central teams still do a lot of the technical analytics, probably the more of the innovation side, building big solutions. Auditors themselves are becoming more data enabled. They're starting to perform analytics themselves with a central team to then support them. So the shift is moving from having this large central bulk of coders where people in the audit teams don't understand it or know what they're doing, to the audit teams themselves starting to do more. This leads to quite significant training considerations. And to get a fully digital enabled audit team, you need two key pieces of training. You can't just give auditors technical training on how to use either the low-code tools, how to use Gen AI, etc. They need to be trained on how to apply that analytics as well. So here there's several things. And the first one on how to use the tools. There's also the understanding of data. You can't just say to someone, I'll show you some of the low code tools later on, here's a low code tool, now go off and do your data analytics, because if they don't have that understanding of the data underneath it, there will be problems. So a good example of this that I use in my training is if you get a piece of data and you start looking at it and don't understand the data, you might get some mistakes. So if I'm looking at mortgages that have been approved and I've got a flag in there that says, has it been approved? And I do a filter on where everyone's been approved equals yes. If I haven't looked and understood and profiled the data first and they've changed it to Y halfway through, you've lost half your population straight away. So you can't just go straight, this is a tool, how to use it. There's also a technical skill set that goes around that, and that needs to link into technical training. Then the digital training on when and how to apply data analytics. So especially with these more advanced ML, AI, Gen AI, we need to know when to use it. Just because you know how to do k-means clustering doesn't mean you should necessarily do it. Just because you can draw a network diagram, you shouldn't necessarily just hop to that straight away. You need to understand what to apply and when. And that goes from understanding the data, understanding where your data comes from, then looking at the data and applying the right tests. Things that people jump into as auditors typically sometimes is, I've got this tool, I can write 50 analytics tests, off we go. The problem with that is you've then got 50 to then do the exceptions from. Perhaps you can use tools to help you with that and some of the new innovative tools that we've been talking about today. But at the moment, you need to really understand the skills involved in that, and the auditors need to understand what they want to write and what they want to get out of it. What are the key controls that I'm looking at? What is this process and what are the risks around it? So to get this fully digital enabled audit team, you need the two of them to be working together to understand. So I'm going to walk through, and I've gone slightly onto AI, ML, and put some of my old DA in there as well because I couldn't help myself. But I want to talk about the different types of analytics that you will typically see and touching on some of the new ones. I've intentionally not touched Gen AI because I know my good friend Alex had already covered that. So at the top, and this is where it comes to writing a good test, is outcomes testing. So if I'm an auditor here, I don't care what controls are in place. I care about the actual outcome at the end of it. So my outcome here is, have I identified any expenses exceeding the approved thresholds? So to do this, I'd look at the data at the end of it, but I wouldn't look at the controls that are in place before that, because first I want to see if there's any outcomes that have failed any controls. You might then go into more controls testing, which is where you're going to check if controls are operating as expected. So if you look back at my outcomes testing, on that expenses one of the controls might be that a manager has approved it. So I might then do a controls test to check that, or to check that the system prevents users from changing things afterwards. So that's a more targeted test than the outcomes testing. We've then got an area that's relatively new, again, for us, is process mining. So process mining, you're able to take the data and view the process that it's taken. So if I give an example of applying for a mortgage, if you can get the mortgage's data, you can get a unique ID, Zoe's reference number, and you can get all the key activities and the dates that took place. You can then process mine that data to check if it's gone through all the key controls that you would expect. And you can actually do this in some of the low-code tools as well. So there's tools that you can use specifically for this, such as Aris and Solonis, but they can in Nime and Alteryx, you can build your own process mining as well. And the great thing for this is an auditor is it will, you know, from my process diagram that I've typically drawn out at the beginning, I can actually process mine it and it will tell me, did Zoe go through underwriting? Was her mortgage approved? And I can check that all the applications have gone through the key processes and key controls that I'd expect to see during that process. You can also check your SLAs of that. So it might be that I only have 90 days to go from applying for a mortgage to completing the mortgage. And you can use process mining to say, from this step to this step, how many days did it tell me? We've got ITGC testing here. This is quite close to my heart. When I first joined HSBC, I joined in the IT audit team. And one of the things that I wanted to do was to try and use more data analytics within IT audit. And one of the things that I noticed is that because we have a lot of different applications on various global systems for the ITGCs, the same people were being targeted for the same data and the same tests being run multiple times. So if you think of things like your privileged access, like backups, so I built in there a dashboard that updates on a monthly basis with feeds from various systems that allow auditors to go in and check some of their key controls. So you'd look at your application ID and it will tell you, have my backups been completed as expected within the guidance? Have I got any privileged access accounts that aren't controlled? And these kind of things are seen as steer more towards as well as people start to build more. I use the term continuous loosely because I know there's a lot of auditors here, so I don't know another word to use for it, but it's not daily, it's sort of monthly updates. On demand. Well, it gets a monthly feed. So.
Sorry, Zoe, wouldn't that go straight to management though?
Management do look at that as well, actually, in all honesty. But if we're digging into a specific application, it's really helpful to be able to see the granular details, because sometimes it might get summarised up to KPIs. But if you're only interested in one system out of everything, you get the ability to look into it in detail. ML AI. So on here, I've put using unsupervised. For example, K means clustering. I'm going to talk about that one in a minute to look for potential outliers. And then you've got supervised. So things like decision trees to try and identify fraudulent transactions. So on the other side, I know this is technically under here, but I really wanted my document principle. So I pulled NLP out separately and gave it its own header. So using NLP to understand text to look for patterns or exceptions. So things like fuzzy matching, topic modelling, sentiment analysis that I'm going to talk about would obviously all fall under there as well in your audit remit.
So what's NLP, Zoe?
Natural language processing. So anything to do with language typically would fall into there. And then risk-based sample testing, probably one of the oldest ones, most straightforward. You might use your data analytics to say, I only want to look at high-value payments to specific countries. And you'd pull that out separately using your analytics. And then pattern mining. So again, this is one that we're starting to see a little bit more of. And it's not a straightforward yes or no answer with this one. It's trying to find patterns in your data. And a good thing to help do that is network analysis. Now, I don't have examples of this in the tools that I'm going to show later, but both of the tools that I'll show do have network analysis built into them. Obviously, there's limits on that. If you're trying to build a massive network diagram, a network analysis diagram, it's going to be problematic. But with more focused data, you can look for patterns on things. So examples of things you might look at there is looking at relationships between things. So if you're looking at payments between customers or relationships between company owners, for example, you might put that into a pattern mining network analysis diagram, and you might give some a higher risk rating to try and identify where there's potential issues you might want to look into in further detail. So this is sort of like the auditor's toolkit of everything that I see in the whole space at the moment and the way that it's moving, apart from obviously Gen AI, which So I've already mentioned this. What are low-code tools? So does anyone use NIME or Alteryx? Because the next bit's going to be very dull for you guys if you do. No. Alex, you don't count. So a low-code tool is effectively a tool where you drag and drop to do an action. So if I want to load a piece of data, I will drag and drop onto what is typically called the canvas. If I then want to filter the data, I will then drag and drop across a filter. Now, these low-code tools make data analytics accessible to people who are not so technically trained. And I will come to the considerations to this at the end, because obviously that brings some concerns. But effectively, you can train people much easier to use these low-code tools than trying to teach them things such as Python and SQL. I've tried to teach people, more non-technical people, technical coding, and it's quite tricky sometimes. These tools, I do a lot of training on them, and it's much easier and quicker for people to understand how they work. So low-code tools you can use for the basic things. You can do filters, you can do pivots, you can do all those sort of things, but you can also do much more complicated things now in them. So for example, you can do k-means clustering, you can do supervised learning. I actually had a look at Alteryx and took a quick list this morning. There's so much you can do in them. Alteryx even has image processing. So for example, if you've got some PDFs with a signature on and you want to check if all those PDFs have been signed, you can load them in, you can get it to recognize it, and you can do some machine learning over it to identify documents where they potentially have a missing signature. And this is in a low-code tool, so it's not one of the, I can say this because I'm a techie person, not one of the techie sort of people who are then sitting coding it. It's a drag and drop and then it's a configuration. Now, I say low code rather than no code because the majority of things still need some coding to be put in there, but you can configure a lot within the tools themselves. Now, I've put on here 3 tools, and Looker I'd say is more around visualization. So I could have, to be fair, put Power BI and ClickSense on there. But the 2 that I really want to show you today are NIME and Alteryx. Now, both of these tools, you can have either a version on your desktop or you can have a server version. If you want the desktop version of NIME, it is free. So you can go and you can download it, your IT policies permitting, and download NIME, and you can play around with it on your laptops at home now if you so desire. It is an open source software. Alteryx has a license fee associated with it, and if you want to use them on a server, if you're doing bigger data sets, then both of them have a fee associated. I'm going to walk you through an example now of k-means clustering using a low-code tool. So k-means clustering, I think I'm preaching to people who know this already, but just in case, is an unsupervised machine learning algorithm, and you can use this to cluster your data based on similarities. So those of you who are familiar with k-means clustering will have probably seen the IRIS data set, which looks at 150 different flowers. It looks at their petal lengths. It looks at, I think it's a stem as well, I can't remember off the top of my head, and it will effectively try and cluster them together. So in k-means clustering, you might want to use that for a few key things within audit. So you might want to look at transactions and look at how invoice payments, for example, based on frequency or the amount or the timing, and try and identify any clusters that look a little bit unusual. You might want to look at customer behaviour, so categorising customers, or you might want to look at good old, this is what I learned on journals, which was my training ground at PwC. And so for k-means, you might want to look at amounts, account codes, etc., and try and identify some potential outliers. Now, I'm going to show you a video, and this I've got to talk over it, so this is where we pray this works correctly. Before I do that, I'm just going to show you my data. So I've used an example data set I don't know why I picked a hardware store. I know absolutely nothing about hardware, but always in my training, I seem to defer to a hardware store. And it's going to use k-means clustering over these expenses data. So this is a sample of the data below, and I've got an ID, and this is my staff number here, how much they've spent on travel, accommodation, meals, entertainment, and the days since it's been submitted. So what I'm going to do is I'm going to load that into KNIME, and I'm going to run k-means clustering over it. And what you're going to see is I'm not going to do any coding. What I'm going to do is I'm going to drag and drop tools onto the canvas. So this is going to be the exciting bit. Right, my video hasn't started yet, so that's good. So this is what KNIME looks like. Here, down here, you'll see the node repository. So when I said it's a drag and drop, everything in here is effectively called a node. So if you want to input some data, you can drag and drop an input node. If you want to connect to a database, potentially, if you've got some analytics you want to do, there's even things around social media and other things in there. So there's a heck of a lot in there. Please don't ask me what they all do. Google is your friend with this. They will tell you exactly all these things. But you tend to use a typical subset of those. Top here is just saying this is the workspace that I'm using. So the equivalent of saving a file, that's where I will save my data. And at the bottom, you'll see you get an error log, which you get an error log, and you also get a log on most of these tools, which obviously auditors love because you can check all your records have been loaded and what exactly you're doing to it. Right, so what I'm going to do now is play my video and just tell you effectively what it's doing. So I'm going to pull in that file that I just showed you. So I'm going to go off screen, but I'm just going to drag and drop an Excel file into KNIME. So you can see KNIME's automatically recognised that that is my sample expenses data. You can configure some things in here as well if you want. So you can tell it what fields you want, and it will give you a little preview at the bottom. So if I say OK, what's going to happen is when I press that little button at the top, KNIME is then loading that data into memory. So you can see here now that data has been loaded into KNIME. So because I want to do some k-means clustering, I need to normalise my data. So I need my values to be between 0 and 1. So you'll see I grabbed a little normaliser tool, and I'm just saying for all these values here, put them to 0 and 1. And I'll press play again. And what that's done is it's taken that, and if I show you the output, you can see rather than having the numeric values now, it's normalised them, and everything has a value between 0 and 1. So I can do my k-means clustering. Now I'm going to search for my k-means clustering node. I'm going to pull that across. I'm going to have a look at that, and I'm going to say, I want to use all these as my variables, but give me 4 clusters instead of 3. And I'll say, OK. I want it to create a chart, but I want it to have some nice colours on it. So I'm going to pull across a little colour manager now. So you can see everything is just drag and drop, and then you connect it to the previous set of data. I'm going to configure that now. I'm going to pick some pretty pastel colours. And finally, I'm going to ask it to create me a little scatter plot. So I'll drag and drop that across and again connect it. I'm not happy with that. I'm going to ask it to run the whole thing. So I'm just checking I'm okay with how that's configured. We'll say okay. And then I'm going to ask it to run. And what that's done is it's taken that data. It's not a great example, so apologies for this, but it's clustered them into 4 clusters, and you can see the different colours, and I'll show that in a minute. And here what it's done is it's showing how each of those people, it's told me which cluster they went into. So if I want to look at it in a bit more detail, that's how it would work. Now this data set here, I think it was pretty small in all honesty, but that you saw how quickly it runs. You can do loads of other different things in here. There's so much different functionality, and that is completely free. So you can download that and play around and try some of these things. I'm going to ask questions now because I feel like that might be a good point. Yeah.
How can you see what each cluster means contextually?
To go into, you can go into these ones and you can get more detail behind them, but because it's a video, I can't show you anything. But
Thank you, Zoe. I'm familiar with k-means clustering, etc. Blah blah. But what can you, without revealing any sort of detail, can you give us any juicy things that you found in the past? Types of things.
Put me on the spot. Yeah. Alex, going to juice things. I think. Oh, don't make me answer that. Just general exceptions. So anything. I'm not taking any more questions.
I can give one. So
thank you, Alex.
We did it on a named client. We were looking at trades, and we identified a cluster where a particular individual was breaking through trades on a Friday afternoon, and it looks very unusual in terms of why that got flagged. Yeah. That's really when we need the background behind it, because all of this was unsupervised. Right. We looked at the transactions. Turns out the guy that was putting the transactions through on that Friday afternoon didn't work on a Friday. Oh. So the question before, what do the clusters mean? You don't know until you've gone into the data and done that additional identification. Can I ask a question?
No, Alex.
So, very in-depth statistical analysis. So from an end user perspective, very easy to drag and drop. But how do you empower the audit team to know what tools to use and not go back to more traditional, giving the top 10 transactions?
Yeah, that's a really good question. And the problem we've had is people have grown up with Excel, in all honesty. So I've grown up with Excel. My default when I was, before analytics would be to go to Excel. We've had to just impair them and say, please keep using it. If we do 3-day training on actually Ultrix we use now. We use Nime as well. So we do 3 days training, and then we have to make sure that they continue to use it, because if you've done 3 days training, you close it and you look again in 6 months' time, you haven't got a hope. You've completely forgotten. The other thing is support from the central team. So on my diagram before, when I showed that central team, we're very proactively supporting our audit teams, checking that they're using this, making sure they're comfortable with it, and making sure they've got all that wraparound training about understanding it. I say considerations later, but one thing worth mentioning is this is very powerful. You can do something quite quickly and assume you've got the right answer. You need to really check your record counts match, your log runs through, that you truly understand what this is doing. In all honesty, we're moving up a curve at the moment. So the auditors are doing more things like rules, joins, looking for exceptions. This will be the thing that will come when they get more comfortable with that. And we will give additional training on how to understand these techniques as well, because obviously it's so powerful, it could be dangerous.
Can you do, 32-bit Excel was notorious. 65,000, I think, was the limit. Obviously, it's better in later versions. But do you have any limits that you've run into?
Yeah, it depends on your laptop to start with. Obviously, with the server version, it's much quicker. I've run 1 million records through on mine, and I've not had much problem. But on a server version, so I've got something in Ultrix that takes probably about 3 hours. If I run it on a laptop, it takes 3 minutes on the server. So the server version is much quicker. I would say I've probably topped out about 1 million on mine.
My question is, in terms of training and getting people to know what to do when building a workflow here. So as someone who's done k-means clustering myself, I know what you mean here by normalization. It relies on historical data and so on. Do you, given that you expect auditors to do this themselves, do you also run training?
I think it's a level. In all honesty, I put this example in because I wanted to stay on theme, so I didn't get told off by John. But we would sort of use it typically for the more straightforward things at the moment, and we're moving up that curve. So once they're confident with this and really happy with it, and we've got some auditors who are absolutely fabulous with these things, quite complex things.
I want to find out, talking about k-means clustering. So I want to see, are there any other alternatives that this can do, such as Gaussian mixture model? Apparently, k-means sometimes struggle in some clustering. So can this do Gaussian mixture modeling? Has it got that ability?
I don't know everything that's in there off the top of my head, in all honesty, but literally tons in there. Alteryx as well has tons of stuff. This is all open source, so people have been adding things as well. So if you can't find something, if you Google it or chat GPT it, they'll normally point in the direction of somebody who's done something in that area as well already. So you can you can add additional packages in and things that people have developed as well.
Oh, thank you.
I'll show you what it looks like on here. I picked this example just to, as I say, it's not the best example, but just to show that some of the high value expenses there and to show that they'd all got higher averages on the expense values. Now I'm going to show you an example in Alteryx now of sentiment analysis. Now, I've picked a subject that is very close to my heart here, which is cake. So to explain what sentiment analysis is, it's obviously opinion mining and it'll tell you the sentiment behind the text. So I'm very sad if the cake was disgusting and I hated every bite. If the cake was okay and I might buy it again, I'd be neutral. And if the cake was amazing and it was full of chocolate and I enjoyed it so much that I had to take another slice, I would be exceedingly happy. So what we want to do is we want to apply this to not so his cake preferences, but actually a real life situation. So I've got some data here back to my hardware store that I'm auditing. And I want to look at the complaints to see if there's anything that they've received, the feedback, to see if there's any complaints that they've received in the last month. So this is sort of what the information looks like. The staff were friendly, poor quality, etc. Obviously, if there's only 10 or whatever it is on the screen, it's very easy for you to look down and pick out the ones that you want. But if you imagine you've got sort of thousands of records and you want to pull through some of the real negatives or the real positives, you want to use a tool to help you with that. Now, I'm not using machine learning on this. I'll explain why afterwards. So this is in Alteryx. I haven't done a lovely video of Alteryx, but what I have done is showed you what the tools are in Alteryx. So NIME calls them nodes, Alteryx calls them tools, but effectively the same thing. I've loaded my data from Excel. I've removed white space, blanks and uppercase. So both of the tools, what they have, which is really helpful, is a data cleansing node. So rather than having to do all these things, if you're imagining you're trying to do this in Excel and you're having to trim it and you're having to do whatnot, you can actually select the data cleansing node and you can tell it there's much more than this in here, but it's kind of chopped off on my snip. But you can replace your blanks, you can modify case, you can get rid of white space, etc. all in one thing, and you just click it. And then because I'm doing some sentiment analysis, what I want to do is I want to take out some of the stop words. So I don't want to look at the and, the are, the punctuation and the numbers. And again, Alteryx has a very handy little tool here. I've dragged across and I've told it what language I'm talking. I've told it which field to use, and I've just told it to use the default stop words. If I wanted, I can add in my own stop words as well. So if I want to take some more out, I can feed them into there. And then Alteryx has an inbuilt sentiment analysis already. This is a rule-based sentiment analysis tool. So I've snuck one in that isn't ML, but I'll explain that in a minute. And it's called VADA, and it's Balance Aware Dictionary and Sentiment Reasoner, which I think is a bit of a cheat to get VADA. And here you can configure that and tell it whether you want to sort of look more at the negative or the positive, and you can run that. So I ran that and it took very little time. And what it did is it had a good go at classifying based on what I put in there. So you can see the top one, it's done a good job. It's identified that there's no negative in there. There's a little bit of neutral, but overall it comes across as positive. You can have a look at a negative one, poor quality product. The hammer broke after one use. More negative than neutral, it puts it as negative. Now, the only thing I would say with this is it's not perfect. Yep. The one that's a little bit longer here around me complain about my loyalty card, it's not giving me my points. It's not really been able to pull that out into whether it's positive or negative. If you read that with the human eye, you would say that actually I think that is probably very negative because I'm not happy about losing all my loyalty points. Now, that was just using the inbuilt sentiment rule-based analysis. in Ultrix, same as NIME, you can actually use machine learning again if you want to. So what I could do is I could take this and I could relabel it. I could take a sample of my data. I could then train a model in Ultrix based on that, and then I could reapply it and see if I got better results with a machine learning based output. Now, if I wanted to do that, I can actually type it very quickly into ChatGPT and say, how do I do sentiment analysis in Ultrix? And it will give me the steps, and it'll even give you an example workflow that you can look at. And the same with NIME, either or. So my last slide, so I can do one. Low-code tools, the benefits. The workflows are easy to reuse with updated data sets. So this is a really important one. If you've done all your hard work in Excel and then somebody says, oh, sorry, we're going to give you a new data file, you have to copy and paste all your formulae and redo it, etc. With this, all you would do is you would point it to the new Excel file and say, please look at this data instead. Then press play and your results would pop out. Only caveat to that is if somebody's changed your data or changed a field, obviously you would need to handle that first so that you didn't end up with any errors. The drag and drop functionality makes it really accessible to people. Workflows can be shared easily, so even if you don't have a server version, you can email the workflows around within your team and use them. And human errors can be reduced as you can look at reviews properly. So I was doing some training last week actually on this, and it was for more senior people looking at it and saying this is just a high level overview of it. And as they looked at it, because they could see the tools on the screen and see what's gone in, what's gone out, check the record count, see what's happened, you can quite easily track your data through and understand what somebody's done. Whereas if I gave you 100 pages of Python code or whatever, you know, big Python notebook, you're going to have to try, and you're not a specialist, it's really hard to understand it. So it helps for the review as well on this. There are some words of caution, considerations. You saw quite short workflows there. Workflows can become quite large and complex if you're not careful. So imagine if you keep dropping things and you're joining in more data. Few things on that. You need to plan the most efficient solution in the first place, understand what you're doing and don't go the long route to try and get to it. You can also use containers, so you can drop some of your tools into a container and give it a title so that people know what you're doing. And you can also add comments underneath the tools as well, so people can understand exactly what's going on. Training's required so people don't become over-reliant on the tools. So I mentioned at the beginning, you know, I'd think straight away, I've done my filter on yes on my mortgages, but if somebody's put a Y, I've lost all that. So you need to make sure that people do data profiling first. They really understand the data and what they're trying to achieve. It's super important with these tools. So as well as the actual training on how to use them, you need to give them training on how to understand what's going in and what's coming out. And as we move up that curve to more machine learning, that becomes incredibly important as well. Training models and understanding the correct ML models to use can be complex, as I said, so you need to fully understand what's been applied. And then overall, with an increased use of data analytics, it can be challenging to get the required data. So we need to understand where the limitations are, if there's blanks in it, if there's bits of missing data, etc., and need to factor that all in. Okay. Any other questions? Oh, gosh.
I've got a question. So thank you. It's a great session, actually, really informative, and I learned a lot. Have you used it for things like firewall rules audits, control audits?
Access controls, yes, we've done some things on there.
Looking for toxic combinations.
Yeah, we have.
What about firewall?
I haven't done firewall rules myself. You can add things in there to reapply rules and things. So there's what's called a formula node. So if you want to check something's been applied, you can write a formula. And the good thing, I didn't show it on here, but the really good thing about it being user friendly is there's like a little formula button that you can click and it kind of helps you code it. So that's why it's low code. You're not having to think, hang on, what do I put here? And you can put things in. So it's really helpful.
How do you ensure that it does not impact the performance of systems? Because you could run queries which could be quite intensive in terms of compute.
So we neither run it on your own laptop, and we don't tend to connect directly to the data source, or if we do, we would connect to a data warehouse directly. So we wouldn't have any impact on the overall production system. We'd just use either a copy of the data or connect to a data warehouse. It will be slower if you're running on your laptop, but again, you can connect a server to potentially to a data warehouse as well. So our kind of guidance is to stay away from production systems, make sure you have a copy of the data. Any more questions?
It's not a difficult one. So Alteryx now goes with non-audit tools. I imagine there's a lot of insights that you could hand over to first, second line. Have you had any cases where maybe management or maybe the person you're auditing is really interested in what you've done?
Yeah, definitely. First line always interested to see what we've done on these, but also on the process mining as well. So we do, I touched on it briefly, we do quite a lot in the process mining area, and that's one where the first line are really interested to see what we've done, how we've analysed the data and how their process looks. But yeah, we do kind of demo things we've done to first line and sort of share with the caveats that then they line it under their own sort of view.
Simple question this time, Zoe. Any thoughts on where you think these tools might be in the next 3 to 5 years?
It's an interesting one with all the kind of new things coming in, but I think these have still got a life in them. I think they're so useful, and I think the way we've seen it is so many people, once you've trained them on it, and they say, oh, I don't open up Excel anymore. My first go-to is I open up Alteryx or I open up Nime. And it kind of becomes the default because, you know, how many spreadsheets are flying around and things, you know, you typically want to analyse them and look at them. I think it'll be kind of more of a go-to tool. My only caveat to that is I started looking at Alteryx when I was at KPMG, which was around, I'm trying to remember, 2014, 2015. And that kind of is still going now and they're using it much more, but it took a little while for people to get used to it. I think now more people are kind of used to technology and pick it up quicker and start running with it.
Sorry, but what I meant is any ideas of how they might evolve?
Sorry. I think they'll also start looking at how they can integrate generative AI with my assumption. I think I don't really talk out of turn, but
yeah.
Question. You mentioned NLP tools. Can you tell us a few names?
What tool? Sorry.
Natural language processing, NLP.
So in there's I wrote these down actually, some of them. In Alteryx, there's the sentiment analysis, there's the topic modelling, there's text classification, there's word cloud. So in there, so in the Alteryx one, there's tools across the top, and then there's specific text ones that you can look at. Nime will have similar as well. They typically be quite.
And if you look at the code project on GitHub, you can look at all of these things on GitHub. Yeah. GitHub.
Send it to choose.